Okay, in this video, we're going to look at building a proximity sensor, like the one we see here. Now this is my prototype, and I built it using PVC plastic pipe fittings. Now this runs on 5 volts, so you could power it through an Arduino Nano. And inside there's a linear Hall effect sensor. So this sensor will only detect ferrous targets. Like you can see here, it's detecting the handle of my wire stripper. So anything that has iron in it, it'll detect and give an output. So if you have a project where you're doing some machine control or robotics, you could use it as a limit switch or to detect any ferrous type target. Now normally a Hall effect sensor will only detect a magnetic field or a permanent magnet. So in order to detect a ferrous target using a Hall effect sensor, you have to bias the Hall effect sensor with a magnetic field, and that's what this rod does. On the end of this rod there's a magnet, and I feed it into close proximity to the Hall effect sensor, and I can adjust it to get the right intensity so I can detect ferrous targets. Okay, here's my proximity sensor laid out on my breadboard, and you can see it's a very simple circuit. So I have one op amp, a 5534, and I have 2 linear Hall effect sensors, and they're positioned back to back so you have a higher sensitivity, and I have an LED for the output. And normally when we take a south pole facing magnet and we bring it up to the Hall effect switch, Hall effect sensor, you can see the south pole magnetic field enables the sensor and turns on the LED. Now if we bring a ferrous target up to the Hall effect sensor, we get no output. But if we take a north pole magnet and we feed it on the back side of the sensor until it just comes on, you can see it just comes on. Now we're biasing the Hall effect sensor. Now when we bring a ferrous object or a ferrous target up to the Hall effect sensor, it will detect it. So as long as you have that bias present, we could actually make a sensor that will sense ferrous targets. So that's basically what I'm doing in my little prototype. And that same technique is used in automotive sensors, like this one here. There's a crankshaft position sensor, and it uses the same idea. So all you have to do is take this circuit and mount it in some kind of enclosure. Now I used some PVC plastic pipe fittings, but you could come up with your own enclosure. You could be creative, and you could build your own proximity sensor. Okay, here's the schematic diagram of my proximity sensor that I built on my breadboard. And you can see the 2 Hall effect sensors. They're linear Hall effect sensors, the OH49Es. And there's 2 of them, and they're positioned back to back. So pin 1 is VCC, pin 2 is ground, and pin 3 is output. Now both outputs are fed into an op amp, a 5534 op amp, and an op amp drives the LED. Now this LED here is optional. I didn't have it on my breadboard, but you could put that LED in there and it'll give you a better visual indication of off and on. So that's the circuit there. It's powered by 5 volts. So all you have to do is get a north facing magnet and feed it to the back side of the second Hall effect switch. Now when you bring a ferrous object or ferrous target up to the first Hall effect switch, we'll get an output. So that's all you need to build your own little proximity sensor to detect ferrous targets. Okay, I'll go through the inner workings of my sensor. Now there's the 3 wires coming out of my sensor. That's plus 5 volts ground and my sense output. Now on the front of the sensor is where the Hall effect switch and the op amp are on a little circuit board. You can see there. And on the back is my bias magnet. So there's my magnet with my adjusting screw. I could actually vary the depth of the magnet, and that goes inside. That goes in and biases the Hall effect switch on the front of the sensor. Okay, I have the output of my sensor feeding one of the GPIO pins of my Arduino Nano, and I have a little program running. It's a little toggle program that will toggle an LED every time my sensor senses a ferrous target. So if I apply a target, you can see it's toggling the LED. My Arduino Nano is picking it up. Now the output of my sensor transitions are pretty noisy, so I have a little chip on board. You see here, that's a little contact bounce IC which cleans up the output of my sensor, so we get reliable switching on Arduino Nano. Okay, if you don't want to build your own sensor, you can pick up one of these. Now this is an automotive sensor, This is the crankshaft position sensor. You can pick one of these up from an auto wrecker. Now inside here is a Hall effect switch and a bias magnet and some conditioning circuitry, so you get a nice clean output. And there's 3 wires, plus 5 volts ground and output. So this is a very robust sensor. It's got its own enclosure. So if you don't want to build your own sensor, you could pick up one of these. Okay, I have my crankshaft sensor hooked up to my Arduino Nano, and the sensor is powered up through the Nano, plus 5 volts. That's coming from the USB port. And the output of the sensor is fed into one of the GPIO pins of the Nano. And the Nano is looking for a negative going pulse. And when it sees a negative going pulse, it will toggle the LED on pin 13, which is also the LED on the board. So I'll take my screwdriver, and if I tap the sensor, you can see the LED is toggling. So the screwdriver is inducing magnetic field into the Hall effect sensor, causing a negative going pulse. And I could also simulate a gear on a crankshaft. Each time the tooth goes by, it will toggle the LED. Okay, here's my little toggle program running on my Nano that detects the output of my sensor and toggles an LED. Now it's written in Forth, so it's very compact. If you look at the very top, the name of the program is called Proximity, and the first thing it does is init, so that initializes pin 2 as an input and pin 13 as an output. Then it goes into a begin until loop, and that will run until I hit any key and it will come out of the program. So this section here is a little bit of a contact bounce routine, so it cleans up any chatter on the output of my sensor. So when it detects pin 2 going high, then it will toggle pin 13, and that will toggle the LED. Then it goes into another begin until loop and waits for the output to go low, then it'll go back up to the beginning and repeat it over and over again. So in this video, I just wanted to explain how you could take a Hall effect switch and bias it with a magnetic field so you could create your own little ferrous detecting sensor. So you could build your own sensor and experiment with this technique.